Alright, so in this problem, I have x to the power of 4 is equal to 4. So to solve this, I'm going to first start by subtracting 4 on both sides. So then these two cancel out, and now I have x to the power of 4 minus 4 is equal to 0. Now, I'm going to rewrite x to the power of 4 here as x to the power of 2 times 2. Now I have this minus 4, which is the same thing as 2 squared, is equal to 0. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So x to the power of 2 times 2, I can rewrite as x to the power of 2 to the power of 2. Now I have this minus 2 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 2. So now I have x squared plus 2 times x squared minus 2 is equal to 0. So now this gives me two equations. I get x squared plus 2 is equal to 0, and I get x squared minus 2 is equal to 0. So for x squared plus 2 equals 0, I can subtract 2 on both sides, so I get x squared is equal to negative 2. And then I can take the square root on both sides because I want to cancel out this power. So if I take the square root on both sides, the square root of x squared is simply x, so I get x is equal to positive or negative square root of negative 2. And if you guys already didn't know, the square root of negative 2, I can rewrite that as the square root of 2 times the square root of negative 1. And the square root of negative 1, this is actually equal to the imaginary number I. So I get x is equal to positive or negative square root of 2i. Now for this, I have x squared minus 2 equals 0. I can add 2 on both sides. These two cancel out. And I get x squared is equal to 2. Now if I take the square root on both sides, I get x is equal to positive or negative square root of 2. Alright, so in this problem, I have 2 to the power of x plus 4 to the power of x is equal to 8 to the power of x. So I'm going to first start by rewriting 4 as 2 squared and 8 as 2 to the power of 3. So now I have 2 to the power of x plus 2 squared to the power of x is equal to 2 to the power of 3 to the power of x. Now I can actually switch the places of these two exponents. So now I get 2 to the power of x plus 2 to the power of x to the power of 2 is equal to 2 to the power of x to the power of 3. Now I can let 2 to the power of x equal to the variable u. So now if I replace 2 to the power of x with u, I get u plus u squared is equal to u to the power of 3. And now if I subtract u squared and u on both sides, I get u to the power of 3 minus u squared minus u is equal to 0. Now I'm going to factor out u, so I get u times u squared minus u minus 1 is equal to 0. And this gives me two equations. I get u is equal to 0, and I get u squared minus u minus 1 is equal to 0. So as you see, we already have one solution of u. So now to solve this, I'm going to use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I have u is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And this is equal to 1 plus or minus the square root of 1 minus, plus 4 over 2. This is equal to 1 plus or minus the square root of 5 over 2. So these are two more solutions. So now remember how we let 2 to the power of x equal to u. So let's first start with u equaling 0. So we have 2 to the power of x equals 0. And there's actually no solution to this because you can't take the power of a number and make it equal 0. So now we have u is equal to 1 minus the square root of 5 over 2. And 1 minus the square root of 5, that's going to be a negative number, and negative number divided by 2 is a negative number. And you can't take the power of a positive number and make it a negative number, so this is wrong as well. So finally, I have u is equal to 1 plus the square root of 5 over 2. And for this, I have 2 to the power of x is equal to 1 plus the square root of 5 over 2. I can take the log on both sides, so I get log 2 to the power of x is equal to 1 plus the square root of 5 over 2. So I can move this to the front, and I get x times log 2 is equal to 1 plus the square root of 5 over 2. So if I divide both sides by log 2, these two cancel out, and I get x is equal to 1 plus the square root of 5 over 2 log 2. Alright, so in this problem, I have x minus 3 to the power of 4 is equal to x to the power of 4. So the first thing I'm going to do is subtract x to the power of 4 on both sides. So then these two cancel out, and now I have x minus 3 to the power of 4 minus x to the power of 4 is equal to 0. Now, I'm going to rewrite this as x minus 3 squared to the power of 2 minus x squared to the power of 2 is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is going to equal x minus 3 squared plus x squared times x minus 3 squared minus x squared is equal to 0. And now this is the same thing as x squared minus 6x plus 9 plus x squared times x squared minus 6x plus 9 minus x squared is equal to 0, because I just expanded x minus 3 squared. So now I'm going to simplify this to 2x squared minus 6x plus 9 times negative 6x plus 9 is equal to 0. So now this gives me two equations. I have 2x squared minus 6x plus 9 is equal to 0, and negative 6x plus 9 is equal to 0. So for negative 6x plus 9 equals 0, I get 9 is equal to 6x, and x is equal to 9 over 6, which is equal to 3 over 2. So this is one solution of x. Now for 2x squared minus 6x plus 9, I have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 2, b is negative 6, and c is 9. So I get x is equal to negative of negative 6 plus or minus the square root of negative 6 squared, which is 36, minus 4 times a, which is 2, times c, which is 9, all over 2a, so 2 times 2. And now this is equal to positive 6 plus or minus the square root of 36 minus 8 times 9 is 72, all over 4, which is equal to 6 plus or minus the square root of negative 36 over 4, which is equal to 6 plus or minus the square root of 36i over 4, which is equal to 6 plus or minus 6i over 4. And if I divide everything by 2 over here, I get 3 plus or minus 3i over 2. So these are two more solutions. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 27 to the power of 9 over 9 to the power of 3. Now the first thing we want to do is we want to make these two the same base, because if we do that, we could simply divide them with each other. Now, what is a common base of these two numbers, 27 and 9? Well, 3 would work. Now 27, this is equal to 3 to the power of 3. And 9, this is equal to 3 squared. So let's replace 27 with 3 to the power of 3. So now we have 3 to the power of 3 to the power of 9 over, now I'm going to replace 9 with 3 squared. So now we have 3 squared to the power of 3. Now if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 3 to the power of 9, this is going to equal 3 to the power of 3 times 9 is 27 over 3 to the power of 2 times 3 is 3 to the power of 6. Now, if we have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So right here, we could think of a as 3, m as 27, and n as 6. So this is going to equal 3 to the power of 27 minus 6, and 27 minus 6 is 21. So this would be 3 to the power of 21. So this is our answer.